Mark Balzarette here in the workshop again. If you've ever been interested in metal casting, I've got an easy, fun, inexpensive, and creative way to get started. And it's using this. Let's get to it. So let's go over the things you're going to need. The first thing you're going to need is a cuttlebone. The cuttlebone is the internal skeleton or internal shell of a cuttlefish. Cuttlefish is a cephalopod. It's related to an octopus or a squid. Has 8 arms and 2 tentacles. They're fished for food, but they're also fished to use the internal structure of this animal. And the center of this, most of this, is composed of calcium carbonate. It's about 85% calcium carbonate with some carbohydrates as the outside part of it. Let me take one out and show this to you. You can buy these at a pet store. You can buy it in the pet section of a supermarket. They're relatively inexpensive. I've seen them as cheap as about $1.25 a piece or so, something like that. In any case, there's like this harder carbohydrate back on it, and then a softer calcium carbonate. You can actually see some of that come off. Okay, and what this is used for pets is birds need to have calcium in their diet. So when they peck at this, it does 2 things. Number one, they lick it and peck at it, and they eat some of this, and they get that calcium in their diet that they need. But they also are rubbing their beak and biting at it, and it trims and sharpens their beak, which is important for their health. In any case, they're easy to find. And they come about 4 to 6 inches long, like this one. This package that I bought online had 2 of them in here. When they're packaged this way, they're a little more money, but you're only going to do this a couple of times anyway. So, and we're just learning. Okay. So the first thing that we need to do is to have this. The next thing that we want to have is some paper and a pencil to draw with. It's very important to draw or make a sketch of what it is you want to make. I encourage my students to always sketch out the ideas that they have for anything that they want to build, because that really helps you to think through the process of your design. It helps you to eliminate mistakes. Instead of making the mistakes in the building of the product or the model that you're making, you're working those things out on the piece of paper. So that's very helpful. We also need a little bit of a pattern to transfer over to the cuttlebone, so it's important to include that. You need a pair of scissors because we want to cut out that drawing to use as the pattern. You're going to need some kind of a saw. I have a coping saw here, but you can really use just about anything that has a narrow blade because we're going to need to cut the cuttlebone in half, and I'll show you that in a little bit. The next thing is we need a piece of sandpaper because we're going to sand that surface that we're going to actually carve into on the cuttlebone. So it's important to have some kind of sandpaper. It can be anything, not too coarse. This is 100 grit, and it's a sticky back designed for a dual action sander. But sometimes what I do is I take the protective film off the back, and I'll stick it right on a flat surface like my workbench here. This is made of metal, so it makes it easier to take it off again. But whatever you have, but you do need a flat surface, and you'll need some sandpaper. The next thing is you need some carving tools. And my preference for something like this, cuttlebone carving, is to use tools used for clay carving. And that's what I have here. These are very inexpensive, but you can use anything. You can use an X-Acto knife, a razor blade, a ballpoint pen, a pencil, a drill bit, just about anything. You can use anything that you have laying around that will give you the shape that you want. Another thing that I have is I have this set of 3 metal stamps, and this one is a sun, this one's a moon, and this one's a star. And I think I'm going to use the star one. I have an idea for something here that I'm going to show you in a minute. And any kind of depression that you make in the mold is going to make a protrusion in the model or in the cast part that you make. So, you could use a pointy nail to make small impressions, and that will make points sticking out. So if you want to make something that looks like it has spikes on it, you can do that by sticking a nail in or other pointy object, a pencil, not something with a really sharp point, but kind of like a dull, tapered point works the best. So that's all you need to get started with. Most of these things you may already have at home, and if you don't have them, you know, they're inexpensive to buy. So let's get started. So I've started to draw a shape here that I want to use, and I'm thinking something along the lines of a Star Trek Federation insignia, and I think this is a nice simple shape to start with. I drew a couple here. I'm just going to, you know, add another one to this. I'll just try to draw another size here. Try to draw something that will fit onto the Cuttlebone. That's the important thing. And I'm not necessarily trying to reproduce this Star Trek insignia, but rather just get an impression of it. And I kind of like that. That's pretty good. I can modify this. And this goes to what I was saying earlier about working out your design idea on a piece of paper. If I show you this, this is the one that I just drew, and it's kind of symmetrical. I don't want it to look like an arrowhead. This one up here, this one looks a little bit better to me. So it's a good size. It's about the right size. If I get my Cuttlebone and try to overlay this on here, I can get an idea of just how big that is. Actually, that's a little small. We could go with the bigger one. I think we could do the bigger one. Yeah. All right. Well, I like the shape. I like the shape of the large one here. So I think I'm going to cut that out. So I'll use my scissors. Let's take that one out of here. This is a quick process. And again, working with paper makes this very easy to make adjustments in your design. I started out with the design, and then I can adjust it with the pencil. You know, my lines don't have to all be absolutely perfect, and I can adjust my design a little bit with cutting. I want to leave a little bit more over here on this edge, so I just cut a little bit to the side. Same thing here. You just come in here and cut this out. And pull this out of here. Let's trim this out. Wanted to get right into that corner. Good, so that's fine. So that's what I've got so far. Looks pretty good. Alright, it's a little asymmetrical, which makes it more interesting than just an arrowhead. Alright, so I'm going to put this on here, and what I want to do though is I want to look for fitment. I want to see that this is going to fit on here in the width and the height that I have to work with. And I'll explain how this is going to go on here in a second after we cut the Cuttlebone. So let's do that now. So the next thing to do is to look at the Cuttlebone, and I want to look at this and find where it's the widest. Where is its wide point? It seems to be right about there. Okay, and that's where I want to cut this in half. So I'm just going to make a little pencil mark. Okay, just like that. So I know where to cut. And I'm going to grab my saw, and I'm going to start from the harder back because this is a little tougher to get through. So there we go. Now we're getting through it. And this is kind of fragile, so it may crack on you. I'm trying to get through this nicely. Well, that's pretty good. Alright, so the rest of it broke through. That's okay. Alright, we don't have to worry about that, the soft part here. That's okay that broke away. So anyway, now we've got two halves. And you can see that at this point here, they're pretty even. The one piece is a little longer than the other. That's okay. Not a problem. The next thing to do is to sand. So I'm going to take my piece of pressure sensitive or PSA adhesive sandpaper. I peel the back off. And here's a trick. Stick it on a cotton t-shirt and pull it off, and do that a couple of times. And the fuzz sticks to the adhesive, and it makes it easier to pull it off later. It still sticks, but it's easier to pull off. Okay, so I've got that, and let's do a little sanding. When you sand this, you want to go in kind of a figure 8 pattern, and that will help eliminate any rocking back and forth. That way you get a flat surface rather than a rounded curved surface. Now you don't have to do this much because this material is very soft, and you can see already I've gotten this very flat. That's really very flat. That's looking pretty good. Alright, now I'm going to take the other piece. I told you this was easy to do. Take the other piece, let's get it started. Sand. This is why you don't want a sandpaper that's too coarse, because you're going to cut away too much material. Alright, that looks pretty good, I think. Now the next step is we want to take these two pieces. See, that's nice and flat too. Very flat. I'm trying to get it straight to the camera. Okay. We take these two pieces and just rub them together. And that way they make a perfect mating surface. Alright, that's looking pretty good. Now you'll see what I mean in a second when we put our pattern up here. So I take my little pattern that I cut. Okay, and I'm going to lay this on here. And let's see how well this fits. Oh, it's a little big. That's a little too big. Oh, darn it. Now the problem is it's coming right to the very edges. And that's a little too big. So I think what we're going to do is let's go back and cut that first small one out. Let's cut that smaller one out. Here, it's right here. Let's cut this one out here. So now let's see how this fits. And I'm orienting it this way. Okay, the point is going to the end, the flat side, and you'll see why in a second. Okay. So I'm going to put this on here. People today, there are artists, jewelers that are making rings and other kinds of pendants and things with this very process. So it has not been diminished by time. Okay, so I'm just trying to center this up. And you'll see why I'm centering this up in a second. Okay, so the next thing I'm going to do is I have a pointy tool here. I got a pointy tool. Okay, pointy tool. And I'm going to take that and I'm just going to go around, score these edges with this tool, holding my pattern in place. And again, it doesn't have to be perfect. You know, I try to do a neat job all the time, but again, we've got room to play. Okay, now I don't know how well this is going to show on the camera, but once I take that pattern off of here, okay, now you may be able to see. Let's see if you can see that. Now it's kind of blown out. Oh, there we go. There we go. You can kind of see the pattern that I etched into it. Yeah, that's it. That's it. That's better. Okay, so you can see that. So now what we're going to do is take. I'm going to use this this rounded wire-ended tool. It's got two different ends on it here. I'm going to use this little rounded end, this one here, and I'm going to start to remove material from here. And you can see that this is very easy to do. This is very easy to carve. People of any age can do this. Little kids can do this stuff with their parents' supervision, and the parents can actually do the casting. And when we get to the pouring of the metal part, we'll see how easy that is to do. We're not using anything super high temperature, but of course, with kids, it's going to be a process that your parents are going to do for you. But my students do this, and I have high school students and I have college-age students, and they really enjoy doing this. And most of them have not done anything like this ever before, so they find it to be really pretty interesting and kind of exciting to do. Everybody can't wait to see what the result is going to be after the metal is poured. Okay, I'm going to stop talking and I'm going to continue to carve this out, okay? So let's take a look at this once I'm done. Okay, the next thing I want to do here, now that I have my form cut out in here, and that looks pretty nice, right? Don't you think? That looks pretty good. Okay, so I'll probably smooth it out a little bit more, but the next thing I'm going to do is I'm going to cut myself an entryway or a sprue to pour the metal into this. And that's going to be here at the top, and I'm just going to cut that in as a small groove. That's going to start right here, and it's going to feed the material in to the casting, into the center of the mold to make the casting. And this doesn't have to be really big. I'm going to end up cutting this off later on, so you don't have to be real neat about it. Okay, so now you can see that I've got a little bit of a groove here at the top. And then the next thing that I need is a way to pour the metal into this, but I can't pour it into this tiny little hole. So what I'm going to do is I'm going to make basically a funnel at the top of this. So let's cut away an area at the top here on both sides. Again, notice how easily this stuff is removed. This just carves so easily. It's very, very soft. So we're going to make like a half of a funnel shape at the top of this. Let me flatten this top out here a little bit. Let's sand that down some. It looks a little better. Oh, that's better. Oh, no. So look how nice that looks now. It's nice and square. I like that. Okay. So I'm going to carve some more of this out. I'm just scooping this out. I'm trying to get this at an angle that the camera can see with the lighting. I'm scooping that center out, because this is basically going to be a little bit of a basin, like a pouring spout, for where the metal is going to go in. I'm going to make this opening a little bit wider, just a little bit wider. Okay, that's looking pretty good. I gotta say, that's not bad. So now what we need to do is is match up the other side. Now, we could carve something on this side and then match them up. That's a lot harder to do. And as a beginner, I would start with just the plain flat side. But I'm going to show you something we can do in a second that is kind of like a nice little creative touch. Okay, but first, let's match up the other side of this for the opening of the sprue for where the metal is going to get poured into. So I'm just going to dig this out. And while this will work, not being really precise, I always try to do things nice and neatly and precisely. So, but not a necessity. You just want to make sure that this is wide enough that we can get that metal poured in here quickly, because the metal will cool off very fast. So you can see now I've got a little basin there, and I open this up and whew. Okay, there we go. Basin, a small opening. This is a small part, so I don't need a big sprue, although I think I'm just going to clean this out a little bit more. Now, if I cut part of the sprue on the other side of this, okay, which I could do, if I did that, then I would end up with a rounded sprue part on the back of my cast piece. And we don't want to do that, okay? All right, so the next thing that we can do is be a little creative, and I'm going to use my, let's see. Oh, I think I said before I was going to use the star. Let's use the moon on this one. Okay, so this is the orientation of the part. So I'm going to turn this so that the moon is kind of like at a little bit of an angle. And I'm just going to press this in. And there we go. And I got a nice moon shape. Nice moon shape in there. There we go. Now you can see in this close-up the lines that are in this. And these are the growth lines of the bone itself as the cuttlefish grows. And they're also going to be on the side of this piece too. Okay, there we go, light. So a way to bring that out is to use a toothbrush. Let me grab a toothbrush really quick. Alright, so I got a toothbrush. Not one that I'm brushing my teeth with anymore. Okay. And I just brush the back of this. And you can see some of the powder coming off. And what it does is it enhances those growth lines. Try to get the right angle here so you can see that. There we go. There we go. Now you can see those the striations in it, how it grew. And so, when I put these two pieces together, the back side of this pendant will have those lines on it. That makes for a nice texture. So, that is pretty much it for doing this. The next thing to do with this is to cast it. So, we're going to hold these two pieces together and set it up to be cast. That'll be the next thing. Dusty. So before we get too far along in the casting process, I want to talk a little bit about why I chose the shape that I cut out of the Cuttlebone and its orientation. And this is very important when you're casting. It applies more to other processes more critically, but with this it's important too. And you can see that on my model here, I oriented that point, okay, this arrow shape, I oriented this so that the point was at the top, and I cut the sprue at that point. And the reason for that is you don't want to have this reversed where the points are sticking up and the sprue is coming down this way, because then the metal has to reverse direction and try to come up and fill those spaces. And that doesn't work very well. Like I said, it's more critical with other applications. In some instances, when you have no choice, then you'd create small grooves in order to pull air out of those areas and allow the metal to rise up into those spots. But generally speaking, you should always have any kind of fine details and pointy areas, thinner sections pointing down so that gravity is bringing the metal down into the mold. That's it for that. We could talk in more detail about that when we look at some other processes, maybe farther along in a future video. So let me show you what you're going to need to do the actual casting. The first thing you're going to need is some kind of metal to cast this with. And since this is a casting project for beginners, I wanted this to be easy for you to do. And the easiest way to make it easier is to use a metal that melts at a lower melting point. When you have a metal that melts at a higher melting point, you need to have a more robust crucible or a melting dish or something to melt the metal into. You also need a hotter flame or a hotter heat source, whatever you're using, whether it be a furnace or a crucible or a torch to heat this. Something like bronze is really nice to work with, or sterling silver is more expensive, but it's really nice material to work with. I love casting sterling silver. But it requires a lot more heat input in order to get that higher melting temperature. So what I decided to do for this project was to use some pewter. Pewter has traditionally been a lead-based material, but now the pewters are lead-free. This is a tin-based, mostly tin, antimony, and a little bit of copper in this. I will include the source for this in a link below the video. But this material melts at about 525 degrees, and its pouring temperature is around 625, 650. Now, there's a difference between the melting point of something and the pouring temperature. The difference is exactly that. It's the zone between the liquidus of the material and the pouring temperature. And the reason that you have a higher pouring temperature is you want to maintain liquidity in the material from the moment that you take the heat away to the time that you pour it. So as soon as you take the heat away, it's going to start to cool. And if you don't have that pouring temperature correct, you're going to lose enough heat that by the time you pour it into the mold, it will begin to solidify, and you'll get what's called a short shot, or it's an incomplete pour into the mold. And this is a common thing, especially when you're doing this stuff at home. Businesses have, of course, figured out how to precisely gauge what their temperature is, but for home things, we have to do things kind of by eye and from a little bit of experience, a little bit of trial and error. But this pewter material is used for making jewelry. It's very nice material. It's safe to handle because it is lead-free, and it's got that lower melting temperature. I'm going to use a MAP torch, an MAPP torch, which is similar to a propane torch. It burns a little bit hotter. The torch I have can use either propane or MAP gas. You can buy these at a big box store, online. The gas is available at the local hardware store, or at your your do-it-yourself home improvement store. So the stuff is easy to get. I assume most of you probably have a propane torch, and I think that's enough to melt this material, but I'm going to try it and see what happens. So we need the torch. I have that out of the screen. It's behind me here. But you need a spark lighter. I always like to have some kind of tongs in order to grab hot things. You need a pair of gloves, a pair of leather welding gloves. I got a bunch here laying around, so out of camera range. We're going to melt this in a cheap stainless steel measuring cup. This is a half a cup measure with a spot welded handle, so the handle's not soldered on. If the handle were soldered on, the heat from melting this material would melt the solder and this would fall apart. So you want to make sure you've got something where it's spot welded on, so it's nice and strong. And then to extend the handle, I've got a pair of vice grips that I'm going to use to hold the handle. And that's pretty much it for that. The next thing we have to do, though, is we have to put our mold together. We have to attach these two halves. And so this is really an easy way to do this. Put your pieces together, line them up where you want to have them. Okay, which should be easy to do because this is basically a one-piece mold. And I got some masking tape or artist tape, and we can just stick this on here. It sticks very well to this harder shell outside surface of this. Okay, you don't have to be real neat about this. Just hold it on, just so it holds together. And then the next thing to do is get some kind of tie wire. I'm using stainless steel lock wire. This is for securing screws and nuts and things on aircraft, motorcycles, other pieces of machinery. But you can use any kind of wire. You can use some copper wire stripped out of a piece of extension cord, some old piece of wire. Anything like that is fine. So I'm going to cut a piece of this off. Okay, and the way that I like to do this is I will take this and wrap this around. I start out at the edge, okay, like this, and wrap this around. Oh, I hope I didn't cut this too short. I think I did. I cut it too short. Okay, new piece. Cut a new piece. I'll make sure this is plenty long enough. See, trial and error. Okay. So now I can wrap this around. The point is I want to wrap this around twice. And I want to have my point of attachment here, of twisting these two wires together, right at the edge. I want to have it on the edge here. So I'll wrap this around and give it a good twist. You can use a tool to twist this if you want, but I'll caution you, don't go too tight, because if you go too tight, you'll end up cracking the Cuttlebone, and you don't want to do that. So now this is nice and tight together. I'll cut these ends off, bend them around so I don't get stuck. Alright, good. And that's it. So that's all set to go. Now the next thing we're going to need is something to hold this. Okay, so I've got a, this is an industrial sized tuna can that I got from the college. I fished it out of the metal recycling dumpster over in the shipping department. And this is filled with, I have pumice stone in this, which is used for soldering trays for jewelers. And that's what I happen to have, but you can use anything. You can use play sand, dirt, whatever. The idea is that you have a container, a metal container, that you can put this into with some kind of media to hold this in. I just dig a little hole in here, okay, and kind of half bury this. There we go. And it's just to hold this in position, just like that. It's to hold it in position so that if I spill any metal anywhere, it spills into the container, not all over the place and starts a fire. Okay, so that's it. That's all there is to it. So now we're ready to put our metal into our melting pot and melt that material. And once that's liquid, we're just going to pour it right in and we'll have our cast piece. You ready? Let's go. Okay, it's time to start melting our metal. So let's see what we can do here. I think we're just about ready to go. That got pretty hot pretty fast. Very easy to melt this material. All right. So let's see what we got. That melted fast, didn't it? I just propped this up. I wanted you to see how much that button shrank. It pulled metal into it. So I'm curious to see how well this actually pulled metal all the way down into the mold. So once it cools off a little bit more than it is now, we'll break it out and we'll take a look at it. All right, let's see how we did. Some spillage. Not so bad. Another little piece. Okay. So here's the first one we did. Here's the first one. And I can see that there's a problem. And that is the some of the metal poured out from the bottom out of a gap somewhere. Well, we'll find out. We'll find out what the result is. Okay. Let's see. I'll take this tape off. Usually the tape, everything burns off. But not in this case. What did we get? Oh, see? We got a short shot. Didn't completely fill in. Most of the metal ran out. Oh, we got very little in there. Oh, that was a failure. All right. Let's see what happened with this one. Wow. Okay, so that didn't work out so well. So what happened? Well, my theory is that the pewter is, of course, it melts at a much lower melting temperature than, say, bronze or sterling silver. So what happened is it retained the heat longer, it stayed liquid, it didn't solidify once it got into the mold, and it just ran out the bottom. So that was quite a mess. But I have a solution. And I think I have a solution. What I did was I mixed up some plaster, regular plaster Paris, and I coated the edges of this one that I made. I coated these edges with, I don't know how well you can see that on camera. Let's see. Coated those edges. There we go. Now we can see it a little bit. So I coated the edges of it, and I think that will seal up the bottom of this and the sides and prevent this from running out when I mount this in here. So that's what I'm hoping. But I'm even thinking maybe I won't even put it in here. I might just clamp it in the vise gently and make sure I don't crush it. So we're going to give this a try and see what happens. And that's it. So let's see what we can do. Alright, so let's melt some metal and cast this thing. See how fast and easily this melts. This is also way more than we need for this by a long shot, but it's the size ingot I had, so I'm just going to go with it. That's ready to go. Well, I got a little spillage, but it's not too bad. So it's going to take a little bit before this cools completely, or at least solidifies. So let's see what we get. I had some spillage to the back, but you know, it gets stuck in my pumice stones again. But that's okay, we can recover it. I can melt it out. So I'm just going to let that sit. Let's hope this came out good. So this has been cooling for a few minutes, and I think it's time to unveil it and see if we had any success. Let's take a look. There's that material that spilled at the back, but that's not so bad. Oh, just fell off. Alright, let's cut these wires. There we go. You can see how that filled in the back. Ah, very nice. Look how well that worked out. And then I can just trim this off, and I can reclaim this. Easy metal to cut. Okay, so we had some success finally. This is the piece that we cast. I don't know how well you can see it. I'll include a still photograph at the end of the video so you can really get a good look at this. I'll fix the lighting and give you a good close-in shot. I can't really do that with the camera set up here. Well, that's not so bad. Anyway, it came out pretty good. I'm happy that it finally was successful. I think the problem was that, as I stated earlier, the pewter melts at a much lower temperature, and it stays at that liquidous temperature longer than, for example, sterling silver or the bronze would. So if you're, don't want to run into the problems that I had here with this, you can always buy some casting grain, some bronze casting grain. I'll include a link at the bottom of the video for that. and it's more money than what this material is. I think it's a little bit more money, but it does require a fairly hot heat source. You may be able to melt it with this. I haven't tried it. I'm used to using a silversmith's type acetylene torch. But in any case, this worked out pretty well. I'm happy for it. I hope you get a chance to try this. The Cuttlebone process is very effective. This is kind of undamaged to the point where you could almost use this again. When you melt bronze or sterling silver in this, the heat really destroys this. But this is actually in fairly good shape. But I don't know. It would be more fun to experiment with more designs. Also, another thing I didn't mention earlier on is you're going to want something to pour your excess material into. I just happen to have this this little trough, this ingot mold that I got from you know, a bunch of junk I acquired over the years, and it was sitting around and it was perfect for this. So I thought that I should mention that you should have some kind of a metal cup, even a it's very popular. You'll see other people with doing casting on YouTube are using cupcake pans. So anything like that where you've got a little space to dump some material in. You can see this pewter is very shiny. You know, it's nice material. It really is very nice. So you don't need much. Something to melt in. A pair of tongs. It cost me $3 at a flea market. Tag still on it. A lighter to light your torch. Some kind of a torch outfit is necessary. Gloves. You should always have gloves. And don't forget your safety glasses. That's always important. Safety glasses are important to protect your eyes. That's pretty much it. Like I said, this is an industrial sized tuna can that is holding my pumice stone. But it doesn't have to be that. It can just be plain sand, coffee can, something metal. You definitely want metal. All right, and that's pretty much it. If you have questions, put them in the comments below. I'd love to talk to people about it. But have fun.